Welcome to the Grimeton station. Today we have the Centennial of the first commercial transmission of telegrams from SAQ. This was taking place the 1st of December 1924, exactly this date. This was a Monday, and for the celebration today, there's also a message composed by Rick and Eleanor Alexanderson, which are descendants to the inventor Ernst Alexanderson, who has a lot of patents which makes this transmitter to work. So, which we can see now is a photo from that era, 100 years old. So it's an aerial photo where you can see the 6 antenna towers and the station in the lower part of the picture. And to the right we have the radio village where the personnel which run this transmitter were living. Also you can see the small white building to the right, which is the transformer house where we get our power from that building. And now we will look on some other old documents, and that's the machine journal from 1924, 1st of December, which was the start of the first commercial telegrams. And we can see here that the transmitter was started at 9:50 in the morning on the Monday, and the guy who was supervising the transmitter had to write down the temperatures of different parts of the alternator every half hour approximately. So one of the columns shows the air temperature in the building, another column shows the air temperature of the alternator. There is a large friction between the rotor and the stator of the alternator. And we will go down here and have a look at what he was doing with the alternator. We can see here that there are different thermometers where you could read the inlet water. And on the back here we have a thermometer showing the air temperature of the alternator itself. The alternator, we go for a quick tour now to look at the technical equipment. The alternator is driven by a 2-phase induction motor. There is a gearbox with a ratio of approximately 3. And we have the alternator which generates the transmitting frequency, and the rotor is rotating at an RPM of 2115 to create a frequency of 70.2 kilohertz. We also have 2 pressure meters for the oil pressure and for the water pressure. And of course there's a lot of more gauges for temperature and for oil pressure at different parts of the transmitter. So now we'll go down to the auxiliary units, which is important to give some DC voltages and some cooling fans, and also the water pumps are part of the system that's called the auxiliary system. We have here 2 air pumps or fans, which is used to create cooling of some relays and to take out the sparks that occur as well. We have a number of DC generators. This generator is driven by an induction motor and creates a DC for the speed control of the main motor, so it affects the voltage of the drain motor. Over here we have a pair of DC generators which each generate 125 volts and driven by this motor in the center. So we have 125 volts and we have 250 volts for different parts in the transmitter. And we can go down to this area. And here we have the pumps for the cooling water. So they are driven by an induction motor and a centrifugal pump. And we have two of them. Most of the systems are duplicated for reliability. So we will run this pump number 1 today. Over here we have the liquid resistors, these two. So this is the start resistor, which is used to control the current and the torque of the main motor. And this liquid resistor is connected in parallel with the first one when the key is down, the Morse key is pressed down to increase the torque of the motor. Okay. So let's go to the, just to pass the relay corridor, where we can see we have a number of different sizes of relays. We have the incoming telegraphy signal on this relay over here, and then we have a number of larger and larger relays. And the biggest one on top is adding some plates inside the liquid resistors. So now we have a quick tour to the high frequency transformers and the variometer, which is the final matching to the antenna. We have two high-frequency transformers, which each of them takes part of a number of power from the 64 coils, which are in the alternator. So in this bundle, we have 16 of the coils at one end. On the other end of the same transformer, we have another 16 coils. And we have the two in parallel. So it's a total of 64 coils, or actually 63, because of the speed regulator needs one. And they transform or match the generator to the antenna. And for fine matching, we have over here a variometer, which is a variable inductance. And that's the one we use to match the fine, to increase or to maximize the antenna current when we do the tuning of the complete transmitter. Okay, let's go back to the control panel. So here we have the control panel where we do most of the work during starting up the transmitter. So the first thing that will happen is that we will apply the full voltage to the station, and we have now prepared with a number of activities, both the last Friday and also to apply the voltage. So we have voltage into the panel now, and now we will switch on the complete station. So where do we have the operator will now check that we are prepared to switch on, and he is prepared at the emergency switch if something goes wrong, which sometimes could happen. So now we'll apply the 2500 volts to the machinery. And now we hear the alarm bell, and the alarm bell means that we don't have any oil pressure or water pressure at this moment. And now Jan-Åke, who's the operator, will switch off the alarm, and he will go down now and start the water pump. That's the first activity. And we will use pump number 1. And the first things that happens now is that he will bleed the pump from air. So it needs to be full of water. So otherwise it will not start to be able to pump any water. So now he listens until it only comes water without air. And now it goes over to the starting equipment, which is a delta Y starter, which is a 2-step start. And the next step now is to open the outlet valve from the pump on the pressure side. And the pump shall give about 2 bars or 2 kilograms per square centimeter. And the operator who is working with a valve at the moment, that's Jan-Åke. And my name is Robert Peterson, and I'm acting as a superintendent today. And well, describing to you all what's going on and also telling Jan-Åke what to do. And he checks the water level or the liquid level in the liquid resistors, which are used to control the torque of the motor. And that's very essential to keep the speed constant during the actual transmission. So he filled it up with some liters of water. And now we are on the start resistor. That was okay. The next step is to start up the centrifugal pumps. In the liquid resistors, we need to circulate the liquid in order not to get any boiling at the starting moment when we have very high currents through the liquid resistors. So there are 2 relays that should be connected, and it's using isolating gloves because there are 400 volts close by. So now they are pumping the circulating pumps. The next step now is to switch on the alarm system. And we hear the alarm bell, and that's ringing because we don't have any oil pressure yet. So now we will switch on the oil pump, and that's an external oil pump which is for lubrication of the alternator, gearbox, and so on. And now it's time to start the main motor. So Jan-Åke will position himself at the emergency switch again. And when he's prepared, yeah, he's prepared, then we'll try to switch on the motor. Yep. So now you can see that the motor is starting to rotate, and you can also see that the generator at the output, the generator shaft is rotating with a larger RPM than the motor because of the gearbox, which increases the rotational speed by a factor of 3. So now we have to wait until the current consumption for the main motor goes down to around 80 amps or slightly below. So we start with a start current of about 140, 150 amps, somewhere in between normally. And so this is a waiting moment. I could also introduce part of the crew. So behind the camera we have Thomas, and his assistant, who is Bengt, is somewhere else waiting for a moment to assist. And we also have at the mixer control panel, we have Thomas, no, it's Janne, sorry, Janne. And as a Swedish speaker, we have Staffan. And yes, what you hear now is the alarm again, and that's due to that we have a too high oil pressure because we have two pumps, the internal pumps of the gearbox and the external pump, which we now switched off. And as a general backup, we have the chairman of the Alexanderson Association, Fredrik Wiklund. So he will assist if we are not managing everything. Now the current is around 90 amps, so we have to wait a little bit longer until we can continue to increase the rotational speed of the motor. We normally switched on the different equipment one at a time, so we don't get a too high peak current. That was quite essential during the 1920s when the power grid was weaker than it is today. So I guess that we probably could switch on more equipment simultaneously, but we want to be working safely to save the equipment as much as possible. Remember, it's 100 years old and it's still the same parts. So it's really a good quality, I would say. I don't know what they planned, the design, what lifetime they planned for during the design, but it's now 100 years, it's very good. Yeah, now we are down at 80 amps, and now Jan-Åke will switch on the DC generators. And the next step is to switch on the field current on the 500 volt generator, and that will increase the voltage supply to the main motor. So you can hear that the motor revs up. So it's rapidly increasing the RPM now. And we need to have a RPM of around 700 revolutions per minute. And at that time we will switch on the control or the speed regulator. The preparations we did before we started here, we checked all the oil levels. That was Jan-Åke who did that. And we also switched on the knife switches for the power. That is the switches for the 2500 volt supply. And we also switched on the external 50,000 volts supply. Yeah, now we can switch on the field for the alternator. And so we can see that the speed control is starting to take control of the frequency or the RPM of the alternator. So the frequency should be 17,200 hertz. So Jan-Åke has to increase the motor speed a little bit more, and he's doing that by changing the liquid level in the liquid resistors with a remote controls, the buttons that he is pressing at the moment. And very soon we will start the needles on the instruments here to oscillate, and that means that the speed control has started to work. Yes. Yes, we need to further increase the speed a little bit. Maybe you can improve the speed a little bit, like that. So that's a successive increasing of the liquid level in the liquid resistors. And first we start with the start resistor. Yeah, now we are very close to 17.2 kilohertz. That looks quite nice, I would say. And I think now you could start to switch on the variometer control or indicator. And then we need to start the fan. And we will start with fan number 1. So the fan is also started with a delta Y control. And now we also open the inlet of the air, and now we can hear the hissing noise from the air blowing into the relays, the high power relays. Okay, the start resistor looks very well adjusted. So now it's time to yep. And now Jan-Åke is connecting the antenna to the high frequency transformers. And the next step now is to adjust the torque over the motor when we have the key down. And we have a fairly good speed control, even with the key down, I would say. It seems to be very constant. So now Jan-Åke is changing the variometer adjustment to obtain the maximum antenna current. Backa lite. Ja, vi ska se. Det är nog bra, va? Yeah. Okay, now we'll start the punched tape transmitter. So we have a tape which transmits the call sign of the SAQ transmitter. And the call sign is the SAQ. And now we'll check the stability of the frequency and that we have a sufficiently good output signal. So we get around 40 amps of antenna current. So now we will allow the transmitter to run up until 11 o'clock before we start the actual transmission of the message for today. We'll see where we have the camera at the moment. Har du sett Thomas? Ser du honom? Du hör inte mig eller? Ja. Jag tar om det så går jag och byter. Okej. Ja. Okay, Thomas, should we take a walk out to the antenna now? So now we will take a walk. Maybe we lose contact at some moment outside here. Yeah. Here we see the antenna system. Okay, do we have some contact at the moment? Okay, so here we see the 6 antenna towers. Each of them is 127 meter high with a cross boom at the top, which is 40 meter long. On the top we have 8 wires, which is distributing the current between the radiating wires, which comes down from each of the antenna towers. So it's actually not the towers themselves that are connect our antennas, it just keeps the antenna in the right position. And from each tower we have a down lead, which is carries a current of approximately 40 amps, which are the radiating parts of the antenna. The total length of the antenna system is around 2.2 kilometers. At each of the towers there is a coil, which we can have a look on over there, which is used for resonating the complete antenna system for the frequency of 17.2 kilohertz. And during the preparations this Friday, before this transmission, we had to adjust the number of turns on one of the coils. So we added 1 turn of one of the coils to get the resonance within the range of our variometer in the high frequency transformer area. I think we could go back in. And we can see over here that we still have the right pressure of the water pump number 1, which we recently have replaced the gaskets, the gaskets keeping the pump closed from the external air. So we had some problems with that. The pump was sucking air and leaking water, but that has now been corrected, so it seems to work very fine. And we have also got a lot of help from many listeners and so on, so we get quite often spare equipment from different parts of the world, mostly Europe. And also the gaskets we use for the water pumps we have been donated. It's an older type of gaskets. It's 100 years old, but still used in a lot of equipment and propeller shafts in boats. Is one application. But now we have quite a good stock of gasket for the pumps. That's very good. The Grimeton transmitter was built by specific reasons, and it's based on the learning from the First World War, where the cables between Europe or Sweden and well, every country involved in that, between America and Europe, was cut by different parties. So as a learning from that, Sweden decided that wireless connection needs to be built, because most of the important communication was with New York and America. So 1920 that was decided, and 1922 the actual work to build the station was started. And it took only 2 years to complete the station, with the antenna system, the buildings, and even the village where the personnel could live. The budget was around 5 million Swedish crowns at that time. And the actual cost was somewhat less than that, somewhere close to 4 million, I think. So that's not so common anymore. And the personnel that was doing the building, the whole equipment was mostly local, especially with the work on the antenna system and the ground plane of the antenna. That's an important part to get an efficient antenna system. You need a good ground plane, and that is wires that are dug into the ground below the antenna. And there is a total of about 200 kilometers of wires which is lying in the ground below the antenna system. So that's and that was hand dug by people, and that's, well, imagine that you would have to dig a ditch from here down to Malmö. So it's quite a big task to do that. There were no machines to be used for digging. It was hand dug, everything. Okay, let's see how the machine is working. Jan-Åke, are you happy with the performance? Are you happy with the performance? Yeah, okay, very good. Yeah. So we see that the frequency is kept very stable, and I think we have a fairly good antenna current as well. now Thomas is showing on the picture is the knobs where we can adjust the frequency. It's they are part of the frequency regulating system, and we have what we are looking at the moment is the voltage regulators, which is also part of the speed control or frequency control. Now we have a few minutes left until we start the actual transmission, and the transmission is carried out by Kai, who is our key telegraphist, we could say. He's running all the transmissions in reality from when we are on the air, so to speak, from the Grimeton transmitter. And today we are transmitting the message from the descendants of Ernst Alexanderson. The message was composed by them. And their name was Rick and Loreen Alexanderson. Okej. Vi får väl stänga av remsläsaren snart. Ja, någon minut på nu. En minut. We will soon stop the punch tape transmitter, and Kai will take control of the transmission. thank you, Kai, for this transmission. Excellent work. And I would like to remind you all to apply for membership in our association, the Alexanderson Association. It's a quite small cost, about $11 a year. I think it's the value of 120 Swedish crowns a year. And you will be welcome at every time when we are running this transmitter. So thank you all, the audience outside in the world around and the audience here in the transmitting hall. And it will now be time to switch off the transmitter. So yes, we will cut the machine. So we switch off the magnetizing current of the alternator. And now we will try to use the stop control. Yeah, there it goes. It's a remote control to stop the motor. And now we have the DC generator switched off. And now we can hear the alternator reducing its speed. And Jan-Åke is now decreasing the water level or the liquid level in the liquid resistors, so it will be ready for start the next time. If the level is not at the bottom, it will not be able to start the motor. So we do the preparation after we have been transmitting so we have everything prepared for the next transmission. And it takes about 9 minutes for the alternator to come to a complete stop. The next thing we will hear is the alarm bell that will go off after a few minutes now. And that means, or the reason for that is that the oil pressure has become too low. And then at that time, Jan-Åke will switch on the external oil pump, which is sitting together with the on the alternator bench or the chassis. It's also time to switch off the fan. Now it's time to oil pump. It's ringing. Lägg till. Så. Och sen kan you could switch off the fan. Du kan stänga av fläkten. So now Jan-Åke is switching off the fan because it makes a lot of unpleasant noise here. In the old times, the operators working here, they were not allowed to have ear protection because they should hear all the sounds from the machinery, so they could hear when something goes wrong. Du kan ju lägga tillbaka spaken där, motorn. So now we have about 9 minutes. Now it's past about 2, I guess. So it's around 7 minutes left until the alternator comes to a complete stop. And when we have that, the complete stop, we switch off the power to the machinery. That's the 2500 volts that will be switched off with the main switch on the panel here. And as the final preparation, we will switch off or open the knife switches, which connects the antenna to the high frequency transformers. And we will also open the knife switches, which connects the external 2500 volts onto the panel here. We could have a look closer on the alternator. We could look at the gauges over here. Here we see the oil pressure, and this gauge also is the alarm input. It has contacts. When the pointer comes down to low pressure, it connects to a small pin there, and there are relays behind the control panel that is actuated in that case. And there is also a connection, which is difficult to see here, a pin on the upper scale there, so when the oil pressure is too high, we also get an alarm. Okay, now it's time to stop the streaming as well. So thank you everybody for attending this session, the Centennial of the first commercial telegram sent by Grimeton SAQ. Thank you and goodbye.